Hello everyone, thank you for signing in and watching my live stream. Welcome to Geometry. I'm Mr. Matt and this is Dr. Tot. And for the last two sessions we've been talking about patterns and inductive reasoning. We defined inductive reasoning and deductive reasoning and also talked about some related concepts, though not exactly the same, but related concepts of qualitative information versus quantitative information and subjectivity versus objectivity. So remember that, let's start with the latter two. So subjectivity and objectivity, when something is subjective, that means that it's open to personal interpretation and it's not based on a universal truth. It could be based on or can vary on the, based on the tastes and preferences of individuals. So for example, language is subjective. What you find to be a good novel might not be somebody else's favorite or even anything that they like to read. So beauty is in the eye of the beholder kind of thing, meaning that it's open to interpretation. Objectivity, or something that's objective, an objective field of study, is looking for some type of universal truth that goes beyond personal interpretation and can be replicated in different experimentations or in different circumstances by different experimenters. And it doesn't have to necessarily be science related, although science is an objective study. Going forward, then we talked about qualitative versus quantitative information. And qualitative information is when you use descriptors or words to characterize something. So we use the example of 3 cars traveling at certain rates of speed, but we don't, that are undetermined or undefined. However, we can observe that one car is going a certain rate and is being passed by another car, so the second car must be faster than the first car. And if a third car passes the second car, then the third car must be the fastest of them all. So those are relative descriptors, and that's qualitative information. But if I told you that car number 1 was traveling 30 miles an hour, and car number 2 is traveling 35 miles an hour, but car number 3 is traveling 300 miles an hour, now you have a relative sense because of the differences in the speed, because now you have quantitative information to make that judgment or to characterize the situation. So quantitative information is based on numbers. So that's when we introduce the number system into our observations or our studies in order to quantify the different rates or values or things that we're observing. So we're going to be focusing in on inductive reasoning. Inductive reasoning is using observations to establish a rule and then using that rule to determine the next terms in a sequence. Deductive reasoning is kind of the flip side of that. So that's using a rule to establish the next sequence. So that's like a top-down, it's referred to as a top-down methodology of reasoning. So you take other rules from previous experiences and you apply them to a new scenario. It's a rule-based judgment. But inductive reasoning is a bottom-up approach where you're observing, making observations of the situation, and you're trying to pick up on similarities by categorizing or by investigating the relationship between terms. Okay, so we're going to continue looking at examples of inductive, examples of qualitative and quantitative analysis using inductive reasoning. So let me share my screen with you here. We're going to start from just a few examples of using qualitative information to establish a pattern. So I have here 3 lists, 3 patterns. Oops, that's too wide. So 3 patterns that I'd like you to predict the next 3 terms for. And I listed here, you might notice that they're either states or presidents. So I gave you a list of the United States presidents in order of their term. And then I also gave you an alphabetical list of the states just for your reference while answering these questions. So I'm going to give you 5 minutes, and I'd like you to look at each sequence and see if you can determine a rule that's being observed. You might have to look at the list of either states or presidents because it may not be sequential. It may not be just one after the other. Okay, so I'll give you 5 minutes. I'll keep track of the time on the board and update it per minute. But otherwise, you may begin, and then we'll review. Okay, so looking at the first list, we have Washington, Adams, Jefferson, Madison, Monroe, Adams, Jackson. So obviously this is going in sequential order to their presidency, the term of their presidency, and we're not skipping any at all. So the next three terms would be Van Buren, Harrison, and Tyler. For number two, we're kind of jumping down the list all the way to Lincoln, Johnson, Grant, Hayes, Garfield, Arthur, and Cleveland. So the next three terms would be Harrison, Cleveland, and McKinley. Then the third list, let me do that in another color. We have Hoover, Roosevelt, Truman, Eisenhower, Kennedy, Johnson. So we're starting with Hoover. We are right here. So we have, I'm sorry, some of these guys are repeated, right? For the list, my apologies. Ignore those terms. It goes from 25 to 26 now. So we're at Hoover, Roosevelt, Truman, Eisenhower, Kennedy, Johnson. So the next three presidents would be Nixon, Ford, and then Carter. For the fourth list, we're at states. So we have Alabama, Alaska, Arizona, Arkansas, California, Colorado, Connecticut, Delaware. So the next three states in alphabetical order would be Florida, Georgia, and Hawaii. If you have any questions, please let me know. Otherwise, I'm going to change this up a little bit. We're not going to do all four, but let's say I deleted a few of these guys. So let's say I'm going to delete Adams, Madison, and Adams. And then in this list, I'm going to delete Johnson, Grant, Garfield, and Arthur. I'm going to give you 3 minutes. I'd like you to determine the rules, the next three terms in list 1 and 2. Okay, I'll give you 3 minutes. Okay, now if we look at the first list, it goes Washington, Jefferson, Monroe, Jackson. So now we're alternating every other one. So now the next three terms would be Harrison, Polk, and Fillmore. In the second list, now we would have Lincoln. Let me do this in another color. Do green. So now we're going to have Lincoln, Hayes, Cleveland. So you see, you can see that we're skipping two presidents every time. So the next one would be McKinley. Oops. And then skip two, so then Wilson. And then skip two, so then Hoover. So we would have McKinley, Wilson, and Hoover. Okay, if there are any questions, please let me know. Otherwise, let's move on. So that was with qualitative information. Now we're going to look at some examples with quantitative information, meaning with numbers. And there are two different ways that a number sequence, well, there's more than two different ways, but for now, we're going to be talking about two different ways that a number system sequence rather can increase or decrease or change. Either you're subtracting or adding values each time, or the values are in some type of ratio, meaning that you're multiplying or dividing each time by a certain value. So in order to investigate what is going on, you can either take the difference of the two numbers, the difference between two consecutive terms, and see if that is a constant difference between every two consecutive terms, or you can divide the terms, divide the second term by the first term, then divide the third term by the second term, divide the fourth term by the third term. If there's a constant value, meaning that if those different separate calculations produce a constant value, produce the same value, that means that those numbers are in a ratio, a constant ratio of each other to each other. That means that there's a number that those values are being multiplied or divided by each time to obtain the consecutive term. So you either need to subtract the values, consecutive values from each other and see if they have a constant difference, or you divide the values by each other and see if they have a constant ratio to each other. Then you just apply that rule. Once you establish the rule, you apply that rule to the last term to get the next term, and then do that two more times to get the next three terms. Okay, I'll give you 3 minutes. Please look at these two problems. Okay, so if we look at the first sequence, if we try to subtract these values from each other, notice that 300 minus 30 is 270. But 3,000 minus 300 is 2,700. And 30,000 minus 3,000 is going to be 27,000. Those are not the same value. They're multiples of each other, which is curious, but they are not the same number, so this is not a finite addition or subtraction from one value to the other. So let's check if they're in some type of ratio. So instead of subtracting the values, we can divide the values. So notice that 300 over 30 is 10. 3,000 over 300 is 10. 30,000 over 3,000 is 10. Now we have a common multiple that's being applied to each term in order to obtain the consecutive term. So we can apply that rule to find the next three terms. 30,000 times 10 would be 300,000. 300,000, and actually I'm going to use semicolons here because the values themselves have commas in them. So 300,000 times 10 would be 3 million. And then 3 million times 10 would be 30 million. For the second sequence, notice that 450 minus 225 is 225. 900 minus 450 is 450. 1800 minus 900 is 900. So these are not the same values, so this again is not a finite difference or sum of some value and the first term. So let's check division. 450 divided by 225 is 2. 900 divided by 450, the third and the second term divided by each other, is also 2. 1800 divided by 900 is 2. So now we have a common multiple, so we know that each term is twice as large as the preceding term. So the next term could be 1800 times 2 is going to be 3600. 3600 times 2 is going to be 7200. And 7200 times 2 is going to be 14,400. So the next three values would be 3,600, 7,200, and 14,400. If you have any questions, please let me know. Otherwise, I'm going to give you 3 minutes. Please look at these two sequences. Okay, so if we look here, 26 minus 13 is 13. 52 minus 26 is 26. 104 minus 52 is 52. These are not the same number. So this is not a finite sum or difference here. Let's do 26 divided by 13. That equals 2. 52 divided by 26. That also equals 2. 104 divided by 52, that's also 2. So the common multiple here is 2. So if we multiply each preceding value by 2, we'll obtain the proceeding value, or the next value. So 104 times 2 is going to be 208. 208 times 2 is going to be 416. 416 times 2 is going to be 832. For the next values, let's see. So if we have 54 minus 18 is going to be 36. 162 minus 54, that would be 108. So we're not getting the same values here. And 486 minus 162, that would be 324. So these are not, this is also not a sum or a difference. So let's try division. If we do 54 divided by 18, that would be 3. 162 divided by 54, that's also 3. 486 divided by 162 is also 3. So you can use your calculator here. If you take 486 and multiply it by 3, that would be 1,458. If you multiply that value by 3, we'd have 4,374. And then finally multiply by 3 one more time to get your last value of 13,122. Okay, if you have any questions, please let me know. Otherwise, let's look at these two sequences. I'm going to give you 5 minutes. I'd like you to look at both of them, please. Okay, so if we look at these, notice that 66 minus 78 is going to be a negative 12. Excuse me, let me fix that. Negative 12. 54 minus 66 is also negative 12. 42 minus 54 is also negative 12. And 30 minus 42, guess what, is also negative 12. So this confirms that this is a constant deduction of 12. So if we take 30 minus 12, we'd have 18. 18 minus 12 is going to give us 6. And 6 minus 12 will give us negative 6. For the second sequence, notice that 36 minus 27 is 9. 45 minus 36 is also 9. 54 minus 45 is 9. And 63 minus 45, or excuse me, 54 is also 9. So we have a constant addition of 9. So 63 plus 9 would be 72. 72 plus 9 is 81. 81 plus 9 is 90. If you have any questions, please let me know. And then the last sequence, and this will bring us up to the end of class today. So if we look at this, 14 minus 21, it's going to be a negative 7. 7 minus 14, that's also a negative 7. 0 minus 7, that's a negative 7. Negative 7 minus 0, that's negative 7. So if we just continue to subtract 7 here, negative 7 minus 7 is a negative 14. Negative 14 minus 7 is a negative 21. Negative 21 minus 7 is a negative 28. And similarly, 132 minus 121, that gives us 11. 143 minus 132 is also 11. 154 minus 143, 11. And 165 minus 154 is 11. So we are going to continue adding 11 here. So 165 plus 11 is going to be 176. 176 plus 11 is going to be 187. 187 plus 11 is going to be 198. So as always, if you have any questions on anything that you've done today, or we've done today, please let me know either in the live chat function or in the comments below. I'm here for you every day, Monday, Wednesday, and Friday for math, Tuesday for reading, Thursday for writing. The geometry section is sessions, plural, are Monday, Wednesdays, and Fridays. From 7 o'clock to 7:45 every day. Please be on the lookout for my other recorded videos that I'll be releasing very soon. And I hope you all have a wonderful night. And if I don't talk to you before next geometry class, then I hope you have a wonderful weekend. And I will talk to you all on Monday.